Okay, so we're going to be looking at just an overview for your unit here. We're just going to, you'll notice that this unit is going to be going over different types of energy, whether it be chemical or heat. But I'm just going to kind of give you an overview to kind of get you started here. So this short video is going to be on energy. Now, before we even go on, I want you to take a look at this picture and make a guess. What kind of energy do you think is being used here? Now, I'm sure most of you will probably see the cord there, and right away you think electrical, and you're correct there. But there's also another type of energy that's being used and represented by this picture. See if you can tell what it is, and then at the end of the video, we'll go ahead and see if your guess is correct. So we've been talking about work, and you've done some schoolwork on the scientific definition of work. And remember, work is when you have, as far as the scientific definition, is when you have a force and you multiply it by the distance, and that actually gives you the amount of work that is done. Now, I don't know if you remember, but just to kind of refresh our memory, remember if you say you had a piano in the garage and you were attempting to move it, and they're pretty heavy, didn't have any wheels, you weren't able to move it even though you pushed and pushed. So the distance that we moved that piano is actually 0. Now we could say, gosh, we did a lot of work. We tried to push that piano and I put all my strength into it, and I did a lot of work on it. But scientifically, because we do have a force in pounds that we've applied to the piano, but the distance that we would have moved it being 0, force times 0 is work, and that would be 0. Anything times 0 is 0. So the amount of work per the scientific definition would be 0. So remember that work is when a force moves an object. Now, energy is the ability to do work or cause change. Now, take a look at these pictures that are right here. And before we go on, see if you can see any that in your mind, right off the top of your head, represent energy, that they either are energy or they have energy. Would you say a hammer does? Would you say a wave, a moving wave does? Would you say that a baseball player posed ready to hit the ball? Does he have energy? Is he representing a type of energy? So kind of think through that just for a minute. I'm not going to say anything now. And when we talk on the phone, I want you to tell me what you think about those pictures. So you might want to jot them down and be ready to tell me, do you think they are energy or have energy? And let's see, a force is a push or a pull. Yeah, we remember that, I think, from our work unit. Now, there are two main kinds of energy, and probably either from our lessons this time or from, you've probably heard them in previous grade levels too. Because as you know, when we go up through the different grade levels, they give us a concept, and then the next year we have that same concept, but we build a little bit upon it. And then the next year you have that same concept, but you put a little bit more added into it. And so you've probably heard of this. Two main kinds of energy are potential and kinetic. Potential, if somebody has the potential to do something, whether it's the potential to be a great singer or whatever, we kind of say that they have something within them. It's kind of like stored within them. We just need to bring it out. And so potential energy is stored energy. It's not being used right at that moment, but it has the potential to be used. Kinetic now would be energy that is being used. So another way of looking at it would be energy actually in motion. So if you take a look at these pictures here, these three here on the left go with the three on the right. But the three on the left here are representing potential. The three on the right are showing the kinetic energy involved. So here we have a guy that's going to be bowling. He's holding the ball up. It's ready, it's stored. There's energy in that bowling ball that when he throws it down the lane, it can knock the pins down. But right now, it's kind of stored. It's not being used. We consider that potential. Yet over here on the right, when he lets that ball go and it's moving and it's heading down the lane to knock down the pins, we would consider that energy in motion or kinetic energy. Same here with a rocket. Down below, there's all the things where combustion is going to take place. It's going to give a lot of power to that rocket to take off. Right now, a lot of stored energy down here. Here, everything has taken place. We actually see the energy is in motion, pushing that rocket forward and up. So you can see the difference between potential versus the kinetic actually being used over here on the left, just being stored, ready to use, but the potential is there to be used. Now here we have a spring that we're going to push that down. Maybe it's on the floor. You push it all the way down, and when you're holding it down, it's stored. It's not moving. We haven't let it go, and it hasn't gone boing up yet. So we consider that stored energy. It's energy that's not being used right at the moment, but the potential is there. Now when we let it go and that spring bounces up, that energy is being used. So that's energy in motion. So now instead of being potential energy as over here, it's now kinetic energy, energy in motion. So we want to get those straight in your head as we go through. Something you'll want to commit to memory. Okay, so which of these pictures shows what potential energy looks like, and which one shows what kinetic energy looks like? And you probably right away can tell which one is which if you were paying attention to the previous slide. But then kind of think, what is one of the main differences between potential and kinetic energy? Now I want you to tell me here as we go through, are these exhibiting potential or kinetic energy? So here, a dog sleeping. Certainly, wouldn't you say potential? Right now he's not doing anything. He's not moving, but he could certainly get up and run after something, and then he would be exhibiting kinetic energy. But as is potential. How about this one with a rock rolling down the hill? Now, if that rock was stuck on something, or maybe just stop moving there if we were to give it a push. But I think that this drawing is representing a moving something going down the hill. So this would be more kinetic, okay? If it was stationed, that rock was stationed at the top of the hill, getting ready for a push, it would have potential energy. And then as it starts to roll down the hill, that potential energy has become kinetic energy. Same here. That ball is moving on the lane, knocking down pins, kinetic energy there. Here, she's running, kinetic. Now that ball, kind of interesting enough, if that ball is in movement, it would be showing kinetic energy, but when it gets right to the top and it stops momentarily for a split second before it goes back down, then it would be exhibiting potential. It had converted to potential energy just briefly, and then as it fell back down, we would be seeing kinetic energy again. Booker as is potential. Yeah, if we had lifted a book up, we could lift it up, and maybe there was a bug on the table here. We were going to lift the book up and get ready to drop it. Then it would be, while we're holding it up here, it would be exhibiting potential. If we dropped it, it could be kinetic. But as is, at rest here, that would just be potential energy. There's no movement at all. Now this is kind of interesting. Elastic potential energy. I think elastic would be like holding a rubber band and pulling it, stretching it out. And so elastic potential energy is that energy associated with things or objects that can be stretched or even compressed, like that spring that we had already looked at. So, elastic potential energy can be stored in many things, whether it be a rubber band that we pulled out and we're just holding it, ready to let it go. That would be elastic potential energy. We haven't let it go yet. Trampolines, springs, an arrow drawn into a bow where we pull back and it's ready to go. That everything is what do you call? I don't know what you call that. Like that. Whatever's on the bow that you pull back, that string that has elastic potential, and you pull it back, and if we let it go, it's going to change into kinetic energy and send that arrow flying. But right now, when it's pulled back and we're stationary, just holding it, there's that elastic potential energy. Again, it's stored, ready to be used. Same thing with a trampoline here. When you jump down and it jumps down for a minute, it doesn't stay down very long. we have that elastic potential energy, but then it bounces back up really quickly, and then it changes to that kinetic or moving energy very quickly. Gravitational potential energy, things at the top, of something, whether it's kind of called the energy by position or place, usually at the top. And if it's going to, whether it could even be water, like behind a dam that's going to be falling down. Gravitational potential energy. And I found these pictures and I thought they were pretty cool. I don't know how that one on the left is balancing there, but it is. And that one on the right is stationary. So both of these, have the potential to certainly become kinetic energy. But right now, they're a great example of that potential energy, gravitational potential energy. If you were to push either one, especially that one on the left, probably would fall very, very easily, and that potential energy would change quickly into what? Kinetic energy, moving energy. Same thing with that rock on the right. Okay, so go through and see what you think what comes to mind when you look at these pictures, whether they indicate potential or kinetic. So how about number 1? Moving, skateboard down, whatever that is, a ramp or something. So that would be what? Kinetic. How about this one here? Probably he's stationary. It looks like he is holding that barbell at the top, but that barbell is going to fall down. So what would you say at the moment is being exhibited by this particular picture? Looks like potential. Probably gravitational potential energy, and then as he drops it, it would change to kinetic energy. Number 3, kinetic, yeah, moving. How about number 4? Well, there's that bow pulled back. So that would be, if it's, I don't see the arrow there, maybe they've let it go. Maybe if the arrow had been, it doesn't look like they let the arrow go though. It looks like it's still pulled back, we just don't see the arrow. So that would be the elastic potential energy. But if they let it go, let that string go on the bow, boing, that would change into kinetic energy. There's that a moving arrow, that would certainly be what? Kinetic energy. Now, in food, there's chemical energy, such that if we eat it, bonds are broken within the food, and it actually can be digested by us and changed into a form of energy that we can use. So right now, I would say that the food sitting on the table not being eaten would be potential. But it's there. If we eat it, it will change into a form of energy that we can use to move our muscles, move anything on the body. Any of the multitudes of processes that are done in the living body. So we've talked about the main categories, potential and kinetic. And both of these come in many forms, and these are the most common forms. Mechanical energy. Okay, that's the energy of moving parts. So we can actually have potential and kinetic mechanical energy. So this is a pencil sharpener. If I move that thing around right now, it doesn't look like anybody's turning it. So we would say right now that there is potential mechanical energy there. But if I turn it, now it's moving. Now it's kinetic energy, and it's mechanical energy. Kinetic mechanical energy. Same thing with a mouse trap. It looks like it's ready to flip over on a mouse. So I would say that's certainly mechanical energy, because it's going to be, it can move. The potential there is for something to flip over and move. So right now it looks like it's potential mechanical energy, but when that is tripped and that thing flips over, that moving part, that mechanical energy is also then kinetic energy. Same thing on the bike. There's a lot of moving parts there. Not moving right now, but certainly has the potential to. So right now we could say it's potential mechanical energy, which can then be changed if somebody's riding it to the kinetic, the moving form, and it is mechanical energy, the energy of moving parts. Thermal, probably that brings to mind heat energy. Then that would be the heat in an object, which would be the heat that could be radiating off from one of these radiators, or it could be the heat that's coming off of a cup of hot coffee, or it could even be the heat that's now in a snowman as the sun is shining and melting that snow. Chemical energy is energy in chemical bonds of, we talked about that with that one piece of, whether it was a tomato or an apple, energy in chemical bonds of food, gas, batteries, burning wood. And let's see, here we also have the other three different forms of energy. Electrical energy, that's something probably that we use the most. Even found in lightning, it's moving electrical charges, moving electrons. Electromagnetic energy is what you get from the sun. Visible light could be X-rays, it could be radio frequency waves from your cell phone. All of those are electromagnetic energy. Nuclear energy from a nuclear reactor. On the sun, you see that happening. Stars. It's stored in the nucleus of an atom, and I think you've probably gone through previously where how an atom looks, and you have that nucleus right in the middle that has the protons and the neutrons in it. And when atoms are split or joined together, then you have what is called nuclear energy. Okay, so now what I'd like to have you do, write down these on a piece of paper and be ready to share with me when you talk with me on the phone. What kind of energy is in 1, 2, and there might even be a couple in 2, 3, and 4. Now, the interesting thing is, you've probably heard this, energy cannot be created or destroyed. Energy can just be converted from one form to another, and so we call that change from one form of energy to another energy transformation or energy conversion. There's several different terms that can be used. And most forms of energy can be converted into any other form. Now, good example, I've either written it up here or you can just look at the picture. Electrical energy, remember we have the toaster plugged into the wall, and those moving electrons, electrical energy is coming to the toaster, but then it makes heat. And the heat is actually what is browning the toast. So that electrical energy coming in is converted or changed into thermal energy. Now here, chemical energy, remember we talked about the chemical energy in food. And so our body will actually convert or change that chemical energy in the food you eat into mechanical energy, which is the moving parts. Remember, so our arms, our legs, everything's moving. So there's a great example of chemical energy being changed into mechanical energy. And interesting enough, usually in an energy conversion, you usually do get some heat produced, some more than others in any energy conversion. In fact, a lot of times some of the energy can't be completely transformed into another type completely. Some of it is lost as heat energy. Okay, so there are energy conversions or energy transformations. Same thing, energy can be converted or transformed or changed from one form to another. We talked about this. Food has potential chemical energy, but when you eat it, then that energy, the bonds in the atoms are broken down and the energy is now released to our cells to be able to be used. And then after that, we actually, that chemical energy is actually changed to kinetic, moving, mechanical energy because we're running, we're jumping, whatever we're doing. Now, the body can also create heat energy. Remember, we were just talking on the previous page that most energy transformations or conversions, you lose some heat. And that's the same thing. Your body creates thermal or heat energy, and you can sometimes you can feel it, sometimes you can't, because always the molecules in your body are always moving, and they are giving off some of that heat energy when they're doing their moving or doing their mechanical energy moves. So let's see if there's anything else we need to see on this page. Three ways of stating that energy is converted. We've talked about the chemical energy be converted to, actually moving mechanical energy where our body is using it. Our body does create the heat energy because the molecules inside us are always moving. Even when we're sitting completely stationary, we think, oh, we're not moving, but the molecules are moving. Okay, I want you to take a look at this picture, flashlight, and I want you to see if you can see how this is just another example of an energy conversion taking place. So remember, the batteries we consider chemical energy. We put the batteries in here, and then it changes to what? There's wires in there, so it becomes electrical energy, and then we actually see the light and the heat. So one thing that the light is represented by the electromagnetic energy, but also it would be giving off thermal energy, because sometimes you can feel the heat at the end. Put your hand at the end of a flashlight. It's not a lot of heat, but you can feel heat there too. So chemical energy was converted to electrical energy, which was created to electromagnetic energy, and also some thermal energy. Okay, so which one do you think this is? We have an electric pencil sharpener. You have wires, and let's say it's moving. What would you say? Electrical, probably wires. How about the gears and blades if they were moving, if we were using the electric pencil sharpener? Mechanical. Yeah. Now, if we weren't using it, we could say that the electrical has the potential then to change into mechanical, so it would just be the potential mechanical, wouldn't it? But if we're actually using it, then we would say that the electrical is being changed into mechanical right at that time. Mechanical energy, we're using it. How about a heating pad? Heating pad plugs into the wall, wires. There's electrical again. So see, so many of the things that we use are electrical energy that we use, and we convert them to other forms. Here, it's converted to what? Thermal or heat energy for the heating pad. Sunlight. Okay, so we have energy coming down from the sun, and the plant is going to photosynthesize. So it's going to take water, it's going to take carbon dioxide, it's going to take the energy from the sun, and it's going to actually change that energy into a form that the plant can use. And then oftentimes the chemical energy that's inside the plant, then we eat it, right? So it's kind of potential chemical energy, and then when we eat it, we can change it into another form as mechanical, and we've talked about that. Now, what does it mean, the law of conservation of energy? And kind of consider this versus conserving energy. If we talk about conserving energy, turn the lights off when you leave a room. Don't let water just flow through turn it off when you brush your teeth. We're conserving energy, right? We're not wasting it. But the law of conservation of energy is a different story. It just says that when one form of energy is converted to another, no energy is destroyed in the process. So energy cannot be created, it can't be destroyed. So the total amount of energy is the same before and after any process. All energy is accounted for. Now remember, some of it could be lost as heat, but it's still changed to a different form of energy, heat energy. So the law of conservation of energy, a little bit different than we're just conserving energy by turning off the lights. Now, if you have a card, you can take a index card, fold it up, and have the fold on the top. Pull it out, and what do you think will happen when you let go? And so, when you talk to me, see if you can tell me what happened between, and it has to do with the terms potential and kinetic energy. Good example of potential and kinetic energy. Another good example is seeing the conversion taking place is using a pendulum. So here's a pendulum. Let's say it's hanging straight down. I'll pull the ball up way up here, and I'll hold it still. I'm not letting it go yet. If I'm not letting it go, it would be what? Kinetic or potential? Potential. Now, right there it has potential, but as soon as I let it go, what do we have? Then we have kinetic. It's moving. It comes down here. It's kinetic, 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 kinetic. Speeds up, and then I'm slowing down. Eventually, it gets up to here. And if I don't stop it, if it just stops on its own and it gets ready to go back down, just for a split second, we have converted back to potential energy. And then as the ball starts to swing this way, there's kinetic, 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 up to potential. So a pendulum really is a good way of looking at the conversion between kinetic and potential energy. Okay, the water at the top of the falls has gravitational potential energy because it is higher. That's the energy due to position or place. As the water falls, the height decreases, it loses its potential, and the kinetic energy increases because the speed increases. So that potential energy is converted into kinetic energy. There's gravitational potential energy because of position, higher down to lower, just like that one rock. There's that rock going down. Which one is that? You remember? Potential or kinetic? Kinetic, most likely, if it's rolling. So there are, just to review, two types of energy. Remember, potential and kinetic, but then underneath we have those 6 categories that we can put underneath either potential or kinetic, depending on what the process taking place at that moment is. Remember, energy can't be created or destroyed, so all you can do is convert it. You can convert energy we have into what we need. So the energy that we use certainly comes from many sources like fossil fuel, coal, natural gas, nuclear power, sun, wind. And most of this, as we talked about, is converted into electricity, which is electrical energy. So there's our 6 forms of energy. We've gone over those. You want to review those. Now here, when we talk on the phone, I want you to be able to give me 3 examples of your own here. I've come up with some examples here, like, oh, show me an example of chemical energy being converted to kinetic. Well, chemical, remember, in food. Kinetic energy, we eat it and running to class. So look through these, and then I want you to come up with 3 of your own. So when we talk on the phone, you can give me the 3 examples of your own, of conversions of energy from one form to another. And make sure you have the type of energy as well as the example, okay? So you'll have type of energy conversion, example. Type of energy conversion, example. Type of energy conversion, sample. You'll have 3 of them. Same thing with this. I want you to look and then write it down. What kind of, what do you see happening here? Any conversions taking place? This is a magnet here. You can see between the South and North Pole. Anything taking place here? Some are simpler than others. What kind of conversions are going on there? Okay, so that's as far as we are going to go. So what I would like to have you do is just go ahead and give me a call, and then we will discuss some of the things that we've talked about on the slides here, and then I'll be able to give you your points. And I hope this is a good review to kind of get you started on the unit dealing with energy. Thanks for watching. Bye-bye.